Welcome to MvDad.com for simple, stable structural solutions. Log in. In this section, today we will discuss about the slab. Select the floor. Click anywhere on slab element. One will get the slab submenu. For detailed calculation, slab number S1, floor 1, simply supported other continuous one way. As per IS code 456-2000, class 23.2.1, if Lx is less than or equal to 10 meter, these are their coefficients. Left support 0.45, right support continuous 0.6. As per the coefficient method and LD ratio, we are calculating required effective depth. Span divided by modification factor, one can say LD ratio is equal to 90 mm. 20 mm we have considered the effective cover, then total depth 110 mm. At the time of modeling, we collected the data from the user only Lx and Ly, span in x direction and span in y direction. Now we have assumed section effective depth of 90 mm as per the modification factor. Now second stage is to calculate the slab load as per the SIDLL and SILL. From that load, we are calculating the shear, and from here we are calculating the bending moment. This calculation is self-explanatory. One can go through it and can understand. For a moment, we are using the slab 2D frame analysis, and according to that, we have calculated the fixed end moments. Fixed end moments are divided in two parts, for dead load and for live load, which we require for the earthquake analysis. Equivalent bending shear, equivalent working shear, then fixed end moments, slab 3, which is continuous one, it comes under that chain S1 and S3. Now as per the loading cases, max and minimum, we are fixed end moments, left support, right support, S1, S3, we are calculating the distribution factor. In the 2AD analysis, for left simple support, that moment will be 0. At the midpoint, at the midsection, continuous, that we have to evaluate and calculate by three methods: max min, min max, and max max, and two separate: dead load and live load. As I already informed, that which we require for the earthquake analysis. Here we got that working max and min frame movements. At left support it is 0, at right support it is 5.6, which is continuous one. For slab S3, left support is minus 5.6 and right support is 0. Same way for min max and for max max. We are considering the maximum value of this two, 6.5 and 6.5. Similar way for dead load and live load, we have calculated the shear x max from left and right that we have to find out for the maximum movement at that particular point. Ultimately, we got that maximum value 3.99 and 3.95. Shear and bending moment of the slab S1 at floor 1. At left support, working dead shear is 4.78, working shear live load is 1.95. Same way for right support 8.24 and 2.8. For ultimate, that is 1.5 multiplication factor, values are 10.14 and 16.16. The maximum of values these two, we are designing the section. So we have considered and at the support maximum bending moment is 3.99 times 1.5 is 5.985 at the distance of 1.18 from the left support. And according to that, we are designing the slab. 5.98 at the 1.18, shear 16.18, ultimate moment, and section is set. As per the ultimate moment, for grade of concrete 20, RU max is 2.76 and MU max is 5.98. Ultimate movement MUR MX, RU max into B into D factor, which we have calculated, it comes around the 22.36. MUR MX is 22.36, which is greater than 5.98, and section is set. Suppose if the MUR MX is less than MU max, then by reiteration method, our software will take care and it will goes on increasing the sectional size till it satisfies this condition. And accordingly, we have calculated the steel. We have considered 0.3%, which is self-explanatory. One can go through it. Then deflection check, steel in Y direction, at left support top, at right support top, check for shear and check for development length. Again, critical shear, that formula, if it is greater, and safe. If it is less, then again we have to reiterate the section and increase the size. Again, this development length, it is also safe as per the LD max should be greater than LD required. Steel weight, number of bars, it is self-explanatory. Just we are giving the overview for this slabs, what and where we are calculating for the reference purpose. Additional steel, this is the final result. Slab type, slab is one way, S1, simply supported, other continuous. Main steel is Fe415, secondary 250, concrete grade M20, effective cover 20 mm, effective depth 90 mm, slab dimensions 3 meter by 6 meter and 210 mm, quantity of the cement concrete 1.98 cubic meter, main steel along X direction at mid span is 25, number of bars 8 mm dia, and mid span along Y direction 20 bars 6 mm dia. Concrete quantity total for earthquakes section. Now we will see the steel drying. Just we have checked 25 bars of dia 8 mm at 260 mm and 20 bars of dia 8 mm at 160 mm at the top. For slab S1 floor 1. slab loads, what we consider, it's 1.5 and 1.5. For full floor, one can see the steel schedule. Slab number S1, S2, S3, S4 for floor 1. Floor 1. Same way, one can change the floor and see the results for slab for floor 2. I hope I have explained. If any doubt, please WhatsApp or email. Thank you.